Okay, this is another example of, or we could say it's an example we did in class, but it's an application of the nth term form of a arithmetic sequence. So let's suppose that we're asked to find the 15th term of a sequence, and we're given the third term and the 20th term. So what we're going to do is we're going to write down the nth term formula, and so an is equal to the first term plus the common difference times n minus 1. We're going to go ahead and plug in 15 in for the n, and then we're going to figure out what we need to find. So A15 is going to be equal to the first term plus, and then if we plug 15 in, you're going to have 15 minus 1, or you're going to have 14d. Okay, so we're going to have 14d. And so I don't have a lot to work with here. I got this formula here, and we want to find A15, but we need to find A1 and D. We don't have that information. Okay, so what we have left is we can use the A3 as 8, and if we plug that into the nth term formula, you're going to have 8 is equal to the first term A1, and then we're going to plug in 3 in for n, so you'd have 3 minus 1 or 2, so we're going to end up with 2d. So we'll have A1 plus 2d. Okay, and what we're going to do is we're going to plug in H20 into the AN formula again, this formula right here. And let's see what happens when we do that. Okay, so then it'll be 43, and that's going to be equal to A1, and then plus, and then we're going to plug 20 in, so we'll have 20 minus 1, so we're going to have 19 D's. Okay. All right, and now we have to go back to, before college algebra. Well, you did this in college algebra a little bit. It's a system of two equations and two unknowns. And we could solve this by doing the elimination method or the substitution method. It doesn't really matter. We'll end up getting the same thing. I'm going to do what's called the elimination method, and so you want to eliminate either the A1 or the D by adding the two equations. So if we take the top equation and multiply by -1, that'll make that a negative A1, and when we add them, the A1s will cancel. So that's kind of where we're going with this, so that we can solve for A1, and then once we know A1, then we can find the D. So 8 is equal to A1 plus 2D. 43 is equal to A1 plus 19D. So we'll multiply the top equation by -1, and that gives us negative 8 minus A1 minus 2D. And then the bottom equation is 43 equals A1 plus 19D. Go ahead and add. And you're going to have 35 is equal to 17D, so we can divide both sides by 17 to get the common difference D there. Okay. Now the next thing is we got the common difference, so then we can plug that back into either one of those equations. It does not matter. It'll work out the same. But I want to work with smaller numbers, so we're going to plug it into this equation here. Take into account that 8 over 1 is the same thing as, I think it's 136 over 17. And so you're not going to see me write the 8 here. I'm going to write 136 over 17 so that I have a common denominator. So that's where that's coming from. Okay. All right, so 136 over 17 is equal to A1 plus 2 times 35 over 17. Okay, and remember, put it over 1. 2 times 35 is 70, so we're going to do 136 minus 70, and I think that's 66. So that's going to give us A1 is equal to 66 over 17. Okay. All right, so we got the common difference, we got the first term. Now all we got to do is plug it in, and we will finally find that 15th term. So this is going to be equal to 66 over 17 plus 14 times 35 over 17. Again, just to be clear, that's 14 over 1, so we do 14 times 35 and then add 66, and then it's all over 17. So that gives us 556 all over 17 as the 15th term in this series, or sequence, excuse me. And so most likely the ones you see in the book, or if I test you on it or give you a quiz or something like that, they won't have such hideous fractions. They'll be a little bit more reasonable. But the underlying idea is the same here for this type of problem.